Okay, we are back on the robotic island and we are going to start a session of pitches this morning, starting now and up until 12:30. And the first pitcher is Nelson. Nelson Segios for Exobotic. You have 5 minutes to pitch your company.
That's perfect, thanks. I'll just mark een ding nemen. Yeah, okay. Let me just wait for the PowerPoint to come alive. Yeah. All right. So let's quickly introduce Exobotic Technologies. So we're a development company for these new Industry 4.0 classically technologies and try to implement them in easy-to-use solutions for agriculture. So these technologies, these are big data, artificial intelligence, autonomous vehicles, precision robotics, and drones. So we are really trying to find the right technology and try to implement them in an easy-to-use and intuitive way. Before going too much further, I actually wanted to ask the audience, and there's at least a little bit of audience, who are you? Are there any farmers, for example, that are listening now? All right. Are there any contractors, loonwerkers? Neither? Okay, we'll just skip ahead. Because what I was going to say is that mainly some of these challenges that we are working on are definitely things that are easy to recognize by farmers. Probably farming and agriculture is one of the sectors where these new technologies can help the most and that potentially will have the biggest impact. And I'm sure some of these are very relatable. So labor, definitely an issue, less and less people to do these manual tasks. Something we can help with is autonomous vehicles to solve one of these challenges. Next one, pests and diseases, okay? It's something that all of you know without a doubt. What can help with it is machine vision, to work more precise, to have a better overview, and to react potentially even faster. Regulations, definitely the case. There's, apart from the spraying, there's definitely other things going on as well. Stikstof plan, these kind of things. Instead of spraying, we can go to precision spraying. So this, for example, is something we co-developed with Ilvo. And to only spray at the zone where there are weeds, for example, and not blanket spray the whole zone. Last one is expertise. That's something we're seeing more and more often as people, these elderly people who know exactly all the in and outs of a crop, they are getting less and less of them. So what can help with this is, for example, big data. So we collect a lot of data and we can use this data to get the same insights that these farmers with years and years of experience, we can replicate them. Now, to show you something more concrete, what have we been doing the last couple of months and years? One of them is a solution with a camera to automate trunk measurements. So it's a camera with an algorithm that can identify the size of the circumference of each trunk. Another one is the development of an autonomous robot, specifically designed for pépinières, for tree nurseries. And this one has specifically been designed to go over go through the mud. Yeah. Go through the mud, be very nimble. So that's something we've designed specifically for tree nurseries. Before last one is a use case from a Swedish client of us. So they wanted a robot to spray the bed of her. Yep. Let's. Okay. So to spray the borders of her plant bed. So now she's using glyphosate to spray them, but she wants to switch to ecological herbicides. That can take the frequency of the spraying up from once every month and a half to every week. So that would mean a lot of work, manual spraying for 13 kilometers of borders. So we will design an autonomous robot with an intelligent sprayer co-developed with Ilvo to send to her and to give her for evaluation. And the last one is maybe the most recent one, inspired by a farmer who said to me, he's a peas farmer, who told me that if he doesn't find a solution to keep the birds off his field, it wouldn't be worth it to farm peas anymore. So that got us thinking, and so actually we're mainly brainstorming, we're not yet on the right solution. into several solutions to keep birds off your fields with these new technologies. These can range from drones to intelligent lasers that will follow the birds, to sound specifically aimed at where the bird is, or even a little autonomous robot that will traverse the fields and work a little bit like a small Jack Russell chasing the birds away. So if anyone here is interested in these kind of things, please do brainstorm with us on it. Now, I want to ask, what is anyone coming here for? Because we know there's already not farmers and not contractors here. I wanted to know who came here to be inspired, or to people that already have a real solution or a problem inside of their head. I guess most of them came for this, the free beers. But in the end, I think the main point I want to make is I can be up here talking, explaining these technologies to all these farmers. But actually the thing that we would need is probably the opposite. It's really talking to the farmers, because we can push technologies, but in the end it needs to be a real solution for a real farmer. And that's where fairs like this should be coming in. So now I would like to invite everyone to have a look at our booth. We can even do a little demo outside of a pre-programmed routine. And mainly let's discuss all the challenges that you guys might be having and see if technology can help with that. Thank you.
Thank you very much, Nelson, for opening this session. And now Anna. Anna will present Robotie.
Thank you. So let's wait for my presentation to start. Yes, today we are starting and today we are preparing for the presentation. So today it will be just very informal. But I hope you will have a lot of questions at the end. And well, let's start then. So I'm Anna. I'm from Agribex, and our product is Robotie. We also have one Robotie here, and what we are. So our main task is basically to automate farming. So what does it mean to automate? It means that we are putting our Robotie on the field to the farmers, to the real farmers. And the farmers, they can use it for different tasks. They can use it for weeding, they can use it for spraying, they can use it for harrowing, seeding, whatever they imagine, which can help them to automate their operations. Well, what do we focus on? So our Robotie is made like a tool carrier. You can see that the implement is sitting in the middle, which actually allows us to work with the highest precision. That's not only that, we also work very efficiently. So we can work on the field with different speeds, with different implements, and we can improve the efficiency on the field because we can also operate 24/7. So the Robotie does not need any coffee breaks like we do. It does not need to stop overnight, and that's why it's very efficient. It's also very reliable. So when you put it on the field, not only it works 24/7, but also it works from morning till evening, and it does not stop, and it's very reliable. So that we can leave it on the field to provide the autonomous operations, it needs to be also safe. We are a Danish company, that's why safety is first for us. And we put different type of safety systems on the Robotie so that it can work on the field without a human operator. Here, I'm just mentioning some of the operations which we can provide with the Robotie. I mean, I have already mentioned the seeding, while weeding or harrowing, spraying, or other tasks as well. I mean, we have also a Robotie which is working like, with the soil preparation. Like you can see on the picture on the bottom, there is a little bit like, reaching on the field. We can also do transplanting, we can do grass mowing, so it's not really limited to one task. We have really tried a lot, and our farmers, they also have a lot of ideas what they can use the Robotie for. Some just use it with cameras for scouting or for field mapping on the field. Here you can also see that we work with plenty of manufacturers. For example, here you can see the Robotie together with Kult. who will follow up with a presentation after me. So I'll leave a little bit space for them. We can also work with monosems, Denhay, Conskilde, Puttinger, Danfoil. So there are really a lot of possibilities what kind of implements you can attach to the robotic. Here, a little bit more about the safety. I have already touched this topic a little bit, but here, what does the safety system actually mean on the robotic? So robotic can only work on the field when the field is marked. It means that we give the robotic kind of GPS virtual fencing. So the robotic can only work in this area which we provide him. We also use the 3D LiDAR laser scanner, which is here in the front. It does not work with the pointer, but you can come to the machine and I'll show you. This is scanning the environment up to actually quite a few meters in front of the robotic, and the robotic will stop if there is an obstacle which is not moving away approximately 50 centimeters in front of the machine. We also have this red bumper, which you can see around the robotic. So it's around the robotic and around the complete implement. It's very sensitive, and by very light touching of the bumper, robot is also stopping immediately. Then we have remote and online stops. So anytime the operator can stop the robotic when it's working in autonomous mode. Another safety feature is that the robotic only drives forwards. So in the front of the robotic, we have the cameras, we have the bumper, we have the LiDAR laser scanner. So nothing can happen when there is a person in the front. But of course, the area in the back, we can only provide in the manual mode. So that's why the implement, there is no hazard with the implement whatsoever. Other than that, we have also some emergency stop buttons, and we have off-track monitoring, wheel slip surveillance, and also we have a stuck avoidance system. So this is all with the safety. Of course, we are CE marked and we comply with all the regulations and legislative. Here, some technical specification. I will not go all through it because it's a lot. And here you can also see some of the crops we target. You can see a lot of horticulture crops, but we also target arable crops, row crops, so everything really. There is no real limitation. We have a 3-point linkage, so you can put different implements, that was already mentioned, and also very strong engine and strong hydraulics, so you don't have to be afraid to put really anything on the robotic. Here a little bit more about the infrastructure, so what kind of cameras we have on the robotic. So we have a front eye and a rear eye camera, and also a crop eye camera, which is watching the bottom of the robotic. All the data is transferred from the cameras what the robotic collects during its operation. It goes to cloud, and then it goes to our web platform, where you are also doing the geofencing. Here in the web platform, you collect the images, you collect the data from the field, and then you can work with these data. You can actually say to the robotic when it's weeding, okay, robotic, please don't weed the complete field, because on a separate area of the field, we have a little bit more weeds, so there you need to weed a little bit more, but the rest of the field, just leave it. Here it's how it works and how it looks in our system, but these are just few images. Of course, you collect a lot of images when you are on the field, and also if you want to see our software, come to our stand and we'll be happy to show you. That's all from me. It was very difficult to keep all this information in 5 minutes. Thank you for the opportunity, and I'm looking forward to see you at our stand.
And we'll see you again tomorrow morning for another pitch. Again, this is rehearsal. We are welcoming now Sébastien Branche, Eco-Robotics, or you want to do cult before? I don't know if Sébastien is available. If not, we can, yes, he's coming. Yep. So Sébastien Branche from Eco-Robotics, and then we'll have Cult coming up. And then we will have Gérald Tonglet from Agronova, then Lemken, Stino, and Simon Cool for the last speech of the morning.
Oh, hello, I'm Sébastien Branche, sales manager for France and Belgium at Robotics. So I will show you how our machine, our ARA is working. It doesn't work yet. So Robotics is a Swiss company founded in 2014 with the desire to bring the robotics for sustainable agriculture. We started with 2 autonomous robots. It was very interesting for the detection and the localization, but it wasn't fast enough to go directly on the real farms and on the field. So in 2019, we decided to put the technology behind the tractor. So we put 3 robots next together to get a 6-meter machine. And now we can drive at 7.5 kilometers, so we can walk, we can do spot spraying. What is this? So we can walk around 4 hectares an hour, day and night. For a farmer, it's enough to go for vegetables and specialty crops. We also work on corn, sugar beets, and soybean, other crops. Still doesn't work. So now the ARA is a spot sprayer, 6 meters, with 156 nozzles. And we do a spot on the ground of 6 by 6 centimeters. We use artificial intelligence to detect every plant of the crop and every weed. The plant around the crop around 2 centimeters, and the weeds even smaller than 1 millimeter. And then we can apply the chemical. If it's an herbicide, we apply the herbicide only on the weeds, or we can put the fungicide, insecticide, or fertilizer on the crops. And then we save more than 80%. It depends of the numbers of weeds per square meter, but we often save more than 95% chemical with better efficiency, because we can spray a stronger mixture as we don't touch the crop, and there's no phytotoxicity, so we can increase the yield. I wanted to show you a video, but I don't know, it doesn't work. So we have today around 15 algorithms for 15 crops, but even if we don't have the algorithm, we can work with we have one function, we spray, everything is green. So we can work on every crop. We don't have an algorithm for potatoes, for example, but we can work with the all green. We can do a fungicide on potatoes today with more than 60-70% saving. So we adapt for depend of the farm on the production, but we can adapt for every farm. I don't know if you have a question waiting for the video. It will, hopefully, we will see it very soon. But we have. I will give you the orders. The first crop we work on, it's grassland. We can detect rumex and sisal on grassland. We have more than 50 machines in Switzerland working mainly on grasslands. So it's a bit a different function. Here we just target we just spray on the target. We detect rumex or sisal, but we don't mind about all the other plants. And for the row crops, we can detect the weeds. We have we detect 2 categories. Ah, wow. And so we can detect dicotyledon on grass. And today it's only for onion, but in the future we can do it on all the crops. We are able to spray only the dicotyledon or only grass. Thank you. Can use this. Thank you. Oh, it's not the last version. Anyway, I did it shorter, but I will use this one for today. Here it's an example. So for the videos, we drive slowly because we want to see what happens. But in real life, we always drive at 7.5 kilometers an hour. So here you can see the darkest spot. It's where we spray. Here it's a selective herbicide. So the system, it's allowed to touch the crop, like here. As we have selective herbicide, we can touch the crop, but we won't damage it. Even if we touch maybe just one leaf, so we can increase the mixture, to a stronger mixture. So it's more efficient on the weeds. But there's still no phytotoxicity. So here it's selective herbicide, but we can work with non-selective herbicide. Then it's not allowed to touch the crop. The machine is able to work with glyphosate on the crops. So when we use glyphosate, we have a safety zone of about 4 centimeters to be sure there's not one drop on the crop. So we have 6 camera blocks like this. In every block we have a 3D camera that will give the real height of the cameras. And at the same time, it will pilot the height of the boom to be always 26 centimeters over the crop, over the target. It's very important to control the height to be sure that we have the 6 centimeters spot on the ground. Yeah, it's the detection, so you can see it. In green, you have the crop. On the orange, it's the weeds. So you can see big weeds, but also really small, about 1 millimeter. So it's very important to detect very small weeds and small crop because we want to go earlier in the field to be more efficient. Here's the list of the crops. If you want to take a picture. Yeah, so I already told you we are on grassland. I don't know if there's a laser here. No, anyway. We work on grassland, and the second crop now is onions because they have lots of problems to remove the weeds on onions. And they have to go with a standard sprayer many times, 6, 8, maybe 10 times a year. And at the end, they still have some weeds they have to remove by hand. So here we can get better efficiency. We have a stronger mixture, don't touch the crop. We can kill the weeds easily. And we use in combination with mechanical weeding. So now at all we have 150 machines around Europe. And I would say it's 60 machines on grassland, maybe 50 or 60 on onions. In the Netherlands, they use it for volunteer potatoes, in onions or in sugar beets. So it's like for Rumex, it's a target, so we just see the volunteer potatoes. We don't detect other plants. We also work on the green beans, spinach, chicory. big market because next year they will lose the last herbicide, selective herbicide. So we have a lot of chicory in northern Europe, so in north of France, Belgium, Netherlands. We already have maybe 10 machines, and we will get more next year. And we just start now with the carrots. We see a big potential in carrots. There's the same problem the onion growers. And we work on corn, but more for seeds, because they have less chemical on corn than on seeds, than compared to standard corn for the grain. We have a new algorithm for wheat, but we didn't try yet, so maybe next year we can tell more about that crop. But I think I already talked too much because it's 5 minutes. Okay.
Are you done? Okay. Thank you, Sebastian. Woohoo! Next presentation is Jonathan Schaeffer from Kult. And then we will have Agronova with Gérald Tonglet.
Oh yeah.
Put it on the stick. So the remote there. All right.
Okay, here we go. Big crowd. So, now it's a really rehearsal. Can you check the clock? All right. So, we are Kult. We are a manufacturer for weeders. And like you see here, we build specially machines for all different kind of robot brands. So what you see here is a robotic from Agribex. It's our in-row weeder. And I just want to give a quick overview about the systems we are developing. And then we're going to see some videos. So what do we do about robotic? We are developer, manufacturer, distributor, and also consultants for every kind of autonomous driving agriculture vehicle, let's say like that. So if there's anybody interested in, please let me know. Our usual tool setting or our usual machines we are offering are, they are a big pallet. We have a hand-steered weeder, we have a camera-steered weeding system, we have a tractor-mounted in-row weeder. We have different kind of front or tool carrier weeders to offer. We have a big side shift for existing machines, and we are one of the most successful companies in multi-section machines, inter-row and in-row, like you see on the right bottom. So our newest projects we just presented in Hanover at Agritechnica. So there we have the Kulti laser. We are now able to see with AI detecting camera the difference between a carrot and a reed. And we are shooting with the laser with a precision from 2 millimeters. We are shooting the reed till it's dead. That's the Kulti AI laser. The Kulti iScan is also an AI-based camera algorithm. And there we are working with our existing hydraulic actuators, really precise around the crop. In this case, it's a sugar bean machine, here in combination with the finger weeder. We also presented the Kult in-row actuator, electric propelled. It's especially made for NIO, for the new Oreo tool carrier we're going to see later. That's a laser, like I explained already a little bit. It's mainly running in carrots right now, but we are going into all root vegetables in the next year. Like my colleague before said, that chicory is really important right now, so we are on that as well. That's the algorithm. So we see with the AI-based camera all the different kind of reads and also the crop, and then shooting, like on the right side you see it, a laser shot into the heart of the reed, and then it's dying because of overheating. That's the Cultiscan, like I explained before. The special thing about that is that we have a camera between the parallelogram shanks, and that means we have for each camera, for each row, one camera, really close to the crop. Thanks, Sebastian. And and this allows us to really see the difference in a small growing stage. That means we can see the difference between a reed and a sugar beet with a plant size from, let's say, 1 centimeter. And then we are steering our existing hydraulic actuators. Next thing is going to be implementing this one into all the robots, especially the Acrointelli, of course. So that's the in-row actuator, electric propelled. You can't see that one, but you will see it in the video soon. There we see it on the left side. It was the first one, the first version in California last year. And of course you see on the right side the machine we are having here on the floor as well. So the news project is implementing cool tools into the farm suite, because what they have now is rubbish shit. Like you see on the left side, on the right side, we are going into a direction where the farmers are satisfied with again. So that's just one project I want to show. That's actually a tractor-mounted Cultiselect. It was really wet, so the customer couldn't go with the big machine he's owning from us into the fields. But he has X-Seed. And because of the Terra trucks, he was able to go on that really wet field, and we just mounted that tractor machine on it, and it was working perfectly. We have to stay far away, that's why my colleague was zooming there, because otherwise the sensors will stop the tractor. So here we have the Nayo Oreo. There you see the electric actuators working, because on this tool carrier we don't have any hydraulic power on it. And there we have finally the Acrointelli Roboti with the in-row weeder in UK, running here in industry cabbage. That machine is doing, I always say 16 hectares per day in-row weeding. Yes, that's still right? Should be right. It depends on the driving speed, of course, but this machine is really doing a great job, and it's running. It's the first autonomously running robot I know who's really doing a job quite successfully. It is. Yep. So if you have any questions, please come to my booth here and also in Hall 6. There we have some more machines to show. Thank you very much.
That was great. You're ready for tomorrow. Thank you. And now we will welcome Gérald Tonglet from Agronova. Gérald. Gérald. Where is Gérald? If he's not here, you can come up. Agronova. Alors je vais passer le suivant et il arrive après. Ok, super. You can go up because he's late. So you can go up, yeah. And so we're welcoming Richard Dixon from Lemken. It's Lemken. Agronova will come after.
So, thank you so much. I should introduce myself. My name is Richard Dixon. I'm the Regional Service Manager for Lemken for Northern Europe and Belgium and Netherlands and a number of other countries. My role today is to present two topics to you. First, you can see there the overview of Lemken, and we should say that Lemken are a company that have been in business now since the year 1780. So 243 years of working with farmers, working with dealers, working in producing farm machines. So our core industry really is producing farm machines for big scale farming. And of course, we've seen a big increase in technology and innovation over the past 10, 20, 30 years. We've now reached a point where we need to, where's the clicker? Yeah. We've now reached a point where we need to think about what is the next level. And the next level comes in research and digitalization and protecting the resources like soil and water. And we need to think about the processes of how we get to that next level. It's a dream, but it is becoming reality. And we're there to support the farmers who want to proceed to that next level of farming. I'd like to present to you the topic of mechanical weed control. So here in our booth, just 2 doors up there, we have the IC Weeder machine. My apologies that this is in red. The reason is that Lemken bought the company Steckete in Stad aan Haringvliet in Netherlands in 2018, late 2018. We have since incorporated that completely into the Lemken family, and the machines since September of this year are now all blue, like the one we have in the booth. The IC Weeder is a completely automatic hoeing machine, which is inter-row and intra-row. So it's working between the rows and also between the plants in the same rows. It's available in field scale machines from 1.5 meters in width up to 6 meters working width. And it's capable of around 3.5 kilometer per hour working speeds, depending on the plant distance down the row. That will be the governing factor of how quickly it will work down the row. It's working with cameras underneath a shield. It's working in a controlled light situation, so the shield is completely dark and then lit underneath with LEDs, so that we have a constant to work with. The number of rows depends on how many cameras we need, but essentially we're working in identifying what is a weed and what is a plant, based on green colour or the colour of the weed, but also based a little bit on the size of the plant versus the size of the weed. But then we need to go to what the operator sees. This is the operator terminal, and he sees a live view of what is actually going on at ground level, and he sees that the machine is guiding to the row and it's working between the plants. But then the next level comes with the IC Weeder AI. Artificial intelligence means that we now use, in addition to cameras, we now use artificial intelligence of a massive data bank of photographs of what is a weed and what is a plant, and particularly what is a plant. That enables us to use this machine at an earlier stage. It enables us to use a machine which is working in crops which are grown from a seed instead of a transplanted crop. And essentially then, the weed and the crop could be at a very similar growth stage. It enables us to identify the weeds at an earlier stage and the plants at an earlier stage of 2 true leaves instead of the previous 4 true leaves. Means we can also drive faster because of the dual identification process. And we therefore see a different version there of the operator screen. He sees a different view, but also the camera technology is working alongside the image technology which is embedded into the machine. I'd then like to present you with this topic of combined powers. Probably everyone would see at some stage that image in the press. That quickly became an image which was associated with both Lemken and Krohn as a combined project to work with autonomous vehicles and find how we can make our field scale machines work with robotics. It's very clear for me that the implement needs to be the technology, it needs to be the brain, it needs to be the part which is in control of the whole system. Actually, the machine in front, you can see the blue tractor there on the top photograph, is only a power unit. It's only a stupid power unit. It's only there to drive forwards or backwards or turn around. It's actually there to do as the implement is telling it. From our point, from the Lemken point of view, we need to spend a lot of time to make our existing machines compatible with robots. We need to find what happens if. And we could call this project, What Happens If? What happens if a shear bolt is breaking? What happens if the machine is blocking? What happens if the tractor is getting a flat tire? What happens if? That's the topic for Lemken. That's the point where we start to become implement specific. And implement specific means, and these two are just two very short video sequences. You can see on the left side, we're looking at the flow of soil through the machine. And we need to have sensors which measure the stress on the tines. We need to have camera technology looking at the finished result. We need to say what happens if. And on the right side there, what happens if a tool is broken? What happens if a shear bolt is broken? What happens if the tines are worn to such a point that they don't do a good job anymore? So for me, it's what happens if. That's Lemken's involvement in robots. I don't believe that we will be selling a robotic tractor, but I believe that our machines will be developed to work with robotic autonomous vehicles. I think that's pretty much all from me. I would invite your questions and also invite you to our booth, just 2 doors, 3 doors up there, and also in Hall 6, where our main stand is situated. Thank you. Thank you for listening.
Thank you very much. Woohoo. And I have all my questions.
You have questions for me?
Yeah. But is Gerard Tanglay here? Yes, he's here.
He's here.
Yes. Are you on your booth somewhere?
Yes.
So I'll come see you after the pitch.
Yeah, it's
the
fine.
pitch, okay?
Yeah, I'll be there.
Thank you, Richard. Oui, bien sûr. D'accord, vous voulez faire qui? Non. Mais c'est 5 minutes pour présenter la société, c'est tout. Hein. Est-ce qu'il y a quelqu'un d'autre qui
Je vais demander à mon collègue qui lui vient de Nayo, que moi j'accompagne aujourd'hui,
Allez.
voir si lui est capable.
Super, super. We're waiting for the next one. No. But
Okay. Hello, everyone. I will present to you today some information about Ilvo. Ilvo also has a booth here. You are very welcome to visit. And I'm presenting what we do around robotics. We prototype robots within our living lab, Agri-Food technology. First, a bit of word about Ilvo. So Ilvo is a research institute in Flanders, here not so far away from. You see at the bottom our facilities. So we have quite a lot of fields where we can do lots of research. We have also stables, we have greenhouses, we have a lot of infrastructure, a lot of labs, and we do research with those infrastructures related to agriculture, fisheries, and food. One of the things that we do also is interact with stakeholders at Ilvo. So one way to do that is through living labs. I'm not going into detail about all our living labs, but I'm going to represent you one living lab. So the living lab, Agri-Food technology. This is the living lab where I am the coordinator. Within this living lab, we develop new innovative solutions for the agricultural sector. To improve efficiency and also sustainability. And here you see an example of a demonstration event that we did in the beginning of this year. So you see one of our robot platforms active on the field, actually mechanically hoeing in between the crops of the field. Within our living lab, we have we apply an iterative design cycle where we first analyze a problem, we design a first prototype, we test it, and then we evaluate it in practice conditions. And this is a cycle that we often need to repeat a few times before coming to an implement that works in practice. That's due to the inherent variable conditions that we face in agriculture nowadays. Of course, demonstrating that technology and advising new companies with our knowledge is also one of our goals. So our main customer of our living lab is, say, the technology company who can come to us to have assistance in the lower TRL levels, in the lower technology readiness levels of their development, do tests on our fields, and have our team working together with you on a few prototypes. Here you see an example of such a project, the CMAT robot that we have built. It's not present here today at the booth, but it's currently undergoing some revisions. You see here that we do the design. We have also a lot of knowledge about the mechatronics and the software, of course. Based on the specific end-user requirements, of course, different components need to be selected. And these are some processes we do, of course, when we design a prototype. Here you see some images about our workshop. So, of course, we build prototypes. We have a workshop to build those kind of things. We have metalworking machines, CNC controlled or conventional machines, and also technicians to assist in creating these kind of things. Also, next to mechanical, also electrical and automation, of course, very important. In the slide to the right, you can see our colleague Sébastien, who is doing the electrical wiring on the Just E, the electrical tractor that we have built. Here are some examples to finish with. So an example is here the CMAT robot, as you saw already in the beginning. This is a multi-purpose robot platform which we can use for sensor applications, but also for weed burning or mechanical weed control. It can be controlled using a task map, for example, or also through real-time sensor development. It doesn't want to go to the next slide. Okay, here you see an example of that iterative development process. So in the left you see the CMAT robot in 2020, And to the right, you see its current form. So we made some adaptations, of course, not only in terms of software, but also in terms of hardware. You see, for example, that another frame has been mounted in between to enable also the use of bigger implements. It's an implement carrier, so the more implements it can carry, the better, of course. Next slide. Here is another example, a very small robot platform. It's a tracked robot platform. We applied a precision sprayer that we built also ourselves on it. It uses a multispectral camera to detect weeds and translates that directly in the activation of a certain nozzle to spray only where it's needed. It is a prototype. We applied it in the blueberry fields already, as you can see here at the image. And here you see an example of the platform that we show now on the boot. It's an electrical autonomous tractor that we've built. We started from a diesel version of a machine, which we modified towards an electrical version, and then we applied the same robotic framework to it that we have controlling our other robot platforms. Of course, a tractor is much more multi-purpose compared to an implement carrier, because you also have the PTO. And this way we can also perform, for example, rotary harrowing, as we see here on the slide. My last slide is about a project that we have currently running. It's an Agri-Food TEF project, a big European project in which we offer also services to companies. So we have quite some expertise, as you can see, but we want to apply that expertise next to other competence centers in Europe to serve also companies in making new AI and robotic-based solutions for the agricultural sector. So we can do this in a project form, and the project actually accounts for the costs that come to our personnel for that. If you want more information, you can go to agrifoodtefvlaanderen.be. And that was my first slide. Here you see my contact details. If you have any questions, don't hesitate to contact me or follow us on the socials available on the slide.